Hey math kids, we're going to finish our discussion about recursive functions, this time with quadratics. So we have this data from the first video in this series that we used from a quadratic function. Now quadratics work a little bit different when we're talking about recursive. They're a little more confusing, I would say. So we're going to start off like we did, and we're just going to start off with a sub n. And then we're going to do something to the involving the previous term, but then we need to add something right here. And the way to know what to use there, we're just going to take this column, so the first difference, which was changing, so it was 2, then 3, then 4, and we're going to compare it starting at 2, 3, and 4. So you always compare it to the second step, not just because it's a 2 here, but you start at the second step, the third step, the fourth step, and you want to see how these numbers compare to these numbers. Well, they're exactly the same, and so the thing that goes right here is just n. Now, that probably seems really strange, but let's just test it. So let's say we want to know the third term. We're going to take the previous term, so the a2, and then add n to it, which in this case n is 3, because we chose it to be 3 right there. So that means a sub 3 equals, now the previous term was set to 3, 3 plus 3, which is 6, and that's true. The third step gives us 6. Now let's try it for the next one. So a sub 4, so it's going to take the previous term, and we're going to add n to it. So this time n is 4. And so we say a4, and then the third term, we have it right here, was 6. And we add 4 to that, which gives us, that's an equal sign, which gives us 10, and that is true. So if we want to find the fifth step, we'll say a5, it's going to be a4 plus 5, or the fifth, remember it was n this time is 5. So we just need to know the value of 4, which is 10. So a sub 5 is equal to 10 plus 5, and so that's 15. So we can add that to the table if we want to use that. Okay, now since this is a weird process, I want to do one more, and that's what this data is right here. I think I'll just move it. Maybe not. I don't know what's going on. Alright, maybe I'll just delete this stuff. So the process is going to be the same, but we're going to end up with a different thing that we're adding. So we're going to start off with an equals an minus 1 plus something. Now this one we haven't figured out the common difference. So to go from 4 to 10, we have to add 6. To go from 10 to 18, we have to add 8, and then we add 10. Now if we go further, to verify that this is quadratic, we add 2 to go from there to there, and add 2 to go from there to there. So because those are the same, we know that it's quadratic. But for once we know it's quadratic, we actually want to use these numbers. Remember, we compare them starting at 2. So to go from 2 to 6, we would have to multiply by 3. And to go from 3, or sorry, to add, I take that back, sorry. We're going to add 4. And then from 3 to 8, we're going to add 5. And then from 4 to 10, we're going to add 6. And so it's not quite lining up in the same way, so we have to come up with some expression that represents that. So what I would suggest doing is multiplying start by just multiplying by 2, then multiplying by 3, and then try to subtract things, and you just kind of play around with it. So what I'm going to try, because I'm going to say, so this is my n, so I'm going to say 2 times n, and if I do 2 times n, that would get me to 4, and then I'd have to add 2 to get to 6. So I forced it to get to 6, but now I want to try it with this one. So if I multiply this by 2 times n, so that's going to give me a 6, plus 2, that does work, that gives me to 8. And then try this one, 4 times 2, that works, and then plus 2. So I want to explain that one more time, hopefully in a slightly more coherent way. Okay, so we want to figure out what do we have to do to this number 2 to turn it into a 6. So I just thought, let's try multiplying by 2. So if we do 2 times n, or 2 times 2, that gives us a 4. Now it's not 6, but how can we turn 4 into 6? We can add 2. And so that would add 2 everywhere right there. So this is like my hypothesis. I'm going to say, I think this will work, but let me test it on the next one. So now if I plug in a 3, does it give me 8? So 2 times 3 is 6, plus 2, that is 8. And then we test it with the 4, 2 times 4, that's 8, plus 2 is 10. So this is what we want to put right here. Okay? Now we can use this, and we're going to test it with the fourth term. So we're going to say a sub 4 equals a of n minus 1, so that's a sub 3, plus 2 times, now our n is this thing, so it's 4, plus 2. Okay, we know what the third term is, it's 18, so we can plug that in. And it comes down to simplification. Now when we simplify it, we hope it's 28, because that means it's right. If not, then we messed up somewhere. So 2 times 4 is 8. And then we add those, so 18 plus 10, it is 28. And so the fourth term is 28. And now let's take this and just find the fifth term. That's something we don't know. So we're going to say a5 is a4 plus 2n plus 2. We know that the fourth term was 28. And we know that n is 5. Okay, we multiply that and we get 10. If we add all these, we get 30, 40. So the fifth term, so we can add to our table another data point. And we get, on our fifth step, we should have 40. Okay, now let's test that with our pattern. And we know our pattern should be adding 12. And that is true. We added 12 to that. And then our pattern plus 2. Okay, so it still works out. It's quadratic. If you need additional help, please come to Math Lab. Until then, calculator.